Welcome to the video for C6.1.5 if you're doing combined science, or C6.1.15 if you're doing chemistry. The lesson's the same and the content's the same. So the title's the same as choosing materials. So before we start, what do we need to know from previous lessons? So we're going to talk about polymers in this lesson. And if we think back to C2.2.7 polymer molecules, we learned in that lesson that a polymer is a substance whose molecule is made from many repeating units. So before we start, if you're watching the interactive version of this video, there should be 5 quiz questions coming up in a second. Once you've done that, we'll go on to the new lesson, the new learning. So our learning objectives for today, we need to be able to describe what a life cycle assessment is. We need to be able to explain how the properties of materials link to the usage, which is something we've done before, and evaluate data from a life cycle assessment to choose a product for a particular use. So choosing material, we've come across this before when we did the alloys lesson. We looked at different alloys and their properties and how that linked to what they were used for. So this is a similar thing, except that we're looking at polymers in this particular instance. So all 3 of those, so polythene, PET, and polypropylene, are all polymers. And I've got a use in mind. So I'm on duty in the playground. It's cold. I want to take a hot drink with me so I can drink it while I'm on duty. I need to make this cup. Which of those 3 materials would I use? So we need to look at the different data that we've been given and think about why it would be important. So the cost. I want the cost to be as low as possible because I'm a bit of a cheapskate. I don't really want to spend much money. Strength. Generally, we want materials to be strong. In this case, it's not holding that much, so it doesn't need to be super strong. The melting point and the maximum usable temperature, they're important that that's above the boiling point of water. Because it's a hot drink, I'm going to pour boiling water in from the kettle. That's going to be 100 degrees C. So I obviously don't want it to melt. And it needs to be usable at that temperature. So even if it's not melted, then it might just soften so much that it's not going to be used anymore. So quick summary of those 4. So cost should be low, strength should be high, melting point and maximum usable temperature need to be higher than 100 degrees C. So if we look at these, this data in that context, this is what we find. So polythene isn't really that strong. It's not strong enough. And its maximum usable temperature is 85. So that's completely useless because when I pour my boiling water in, it's going to be so soft, it's going to be unusable. PET is expensive, and also its maximum usable temperature is lower than 100 degrees C. So again, I can't use it for this purpose. Polypropylene, as you can see, there's no crosses by any of that, so that's the material that I would use for making my cup. Right, so we're going to look at life cycle assessments now. So in life cycle assessments, it uses this term cradle to grave. So we think about this in terms of a person. So this is where this phrase has come from. The cradle to grave means from the point at which you're born, and that's because you're put in a cradle, and from the point to where you die. So it's what happens over the entire life of that person. So if we're talking about people, let's say you've got the cradle where you've got the baby has been born. You've then got childhood. You've then got, so we've skipped adolescence there, you've got adulthood, you've then got old age, and then you've got the death. So how is this similar to a manufactured product? So the comparison to the baby being born is the product being manufactured. Okay, so there's the factory where in this case, we're looking at a water bottle. So the water bottle has been made in a factory. That's equivalent to it being born. Okay, then we've got the lifetime of the person, the lifetime of the product, how it's been used. So there's somebody using the water bottle, and then the grave once the product has been fulfilled its useful purpose and now needs to be disposed of. So there's a picture of a landfill there of the rubbish kind of piling up. So what is a life cycle assessment? So a life cycle assessment looks at the impact of an object for its life. So that means from the time it's made, i.e. the cradle, to the time it's disposed of, i.e. the grave. So we've got these 3 pictures here to represent that. So we've got to think about the impact So we're talking about the environmental impact here. And it's the environmental impact in the cradle stage is what raw materials are needed to make that product, what energy is needed in the process of making that product, and what water is used in the process of making that product. Then in our use, we need to think about the energy use. We need to use, when that product is actually being used, we need to think about any energy for maintenance. We need to think about any chemicals for maintenance. So for this example here with the water bottle, none of that's really applicable. You don't use any energy while you're using it. You don't need to maintain it, and you don't need any chemicals for maintenance. But if you were looking at something more complicated, say, for example, a car, then the energy use while you're using it would be your petrol, the energy for maintenance. So cars need to be maintained. There's going to be energy and chemicals associated with that. And then lastly is our grave. So disposal of products requires two things. It requires space for the disposal, and in some cases it needs energy for disposal as well. So all these things need to be considered. So what's the point of a life cycle assessment? So there's three reasons we might do a life cycle assessment. So the first one is seeing which stage has the biggest environmental impact. And that allows us to focus our efforts on reducing impact where it will have the biggest effect. So if I just go back to this previous slide for a second. Oops, sorry, wrong way. So if I go back to this, if it was found, for example, that 5% of the energy use was in disposal, 80% was in manufacture, and only 15% was in use, then we'd know which one to concentrate on. If we're trying to improve the environmental impact of this, we'd focus on the stage that's got the biggest use. So, apologies for this slide; it's come up in the order in the wrong order, but it will still work. So let's keep going. Right. So the second reason you might do it is compare different materials for the same job. So I want to make a window. Would I use wood or would I use PVC? And the last one is that you might compare the same material for different jobs. So, for example, I've got some PVC. Would I use it for cling film or would I use it for buckets? Right, you've actually got a task that you need to do now. So you need to either copy this table down and fill in the statements in the correct place, or I've attached the file for this as an email so you can print that off and fill it in. Okay, now you need to do the same thing for task 2. So again, it's copy down the table and fill in the statements in the correct place. Right, last thing that you need to do, there are some quiz questions. So there's 5 quiz questions to recap today's learning. So if you're watching the interactive version of this, the questions will appear very shortly. Okay, thank you for listening. See you next time.